Dice. I'm the the product line manager for the Galileo board and also for the Quark SoC that's on the board. We've come here today to talk about the board and do a demo of our DataMonster, which is at our Intel Labs. I'd like to introduce Lucas and Carlos, who are the designers and supporters of the DataMonster. And also our good friend Schuyler, who's
I answer all the questions.
Yeah, if you have a question, he's going to answer it. I can't stop him from answering it, so he's going to answer it. Aren't you?
Yes.
Okay. So we've been moving kind of fast. Our CEO, Brian Kersanich, introduced the technology just a few weeks ago in San Francisco, and it has open architecture, open software. The board, which we have designed, is open hardware. It's the first time Intel's done that. It was a departure from what we're comfortable with, but this is where we want to go. We want to be enabling the maker communities to be able to go out and do the things that they do best. And we want to bring that technology from the Intel side to the maker community. We also are supporting all the industry software, like Linux and whatnot, all open source. Again, we run tip of the tree Linux, and we'll get to that again in a minute. And then we're fully synthesizable, which means that the chip which we have, we can design it in any of our factories. So there'll be a lot of longevity with this component. It's not going to be a one-off. There'll be a long series of these chips going forward. So that's important, that we're not going to just make one and stop. You're going to see a whole series of them going forward. Also, which we did this week on stage, is we also announced an agreement with Arduino to work together to bring forward a lot of new boards, various form factors, various sizes, various capabilities, to showcase some of the new Intel architecture and some of the Arduino innovation that they bring to the market, to the maker community, and to the educational community. So this is an eye chart, unfortunately, but it highlights some of the features which we have inside the Quark and on the board. I'm going to start going through it. If you have any questions, just go ahead and raise your hand, and we'll go ahead and do a bit of Q&A. I hope to get through this in a few minutes, and then we can get to the fun of the DataMonster. So we have the Quark SoC X1000, which runs at 400 megahertz. That's an x86 core running at 400 megahertz. It has around just under 500 DMIPS. It depends on the compiler you use and a few variables, but it's around 500 DMIPS of power. We also have embedded in the chip 512K embedded SRAM. On board, we have 256 megabytes of DDR. That means there's no size sketch that you're going to run. You can get much more complex in the sketch drive. We have an Ethernet port on there, USB 2 host port, which is a full host port. It can do just about anything that your PC can do as far as USB goes. We have a PCIe Gen 2 slot in the back, which you can't see from this picture, but that expands capability to add wireless or 3G or PCIe video or a number of different bits and pieces.
The PCIe slot, though, it offers Gen 2 features, but it actually runs at Gen 1 speeds to reduce the power consumption.
But it is full PCIe compliant from that point of view. So we'll work with all of our PCIe Gen 2 products. We also have a micro SD slot and an 8 meg SPI. So the 8 meg SPI, you can put a little Linux kernel in there if you want to. But if you want to add more features and functionality and get to a bigger Linux kernel and full Linux, you can use the SD card, which goes up to 32.
If you want to use any Wi-Fi card, like the Intel Centrino N135 we recommend for this, you need to run Linux off the micro SD card because the drivers for it don't fit on this flash.
That's right. So also, this has been made for development. You have a programmable USB 2 device port, which means you can reprogram that USB 2 device controller to be anything. Right now it says that on the Galileo, but if you want to reprogram it to make it look like something else, you can use that. And you can make your own USB device off of it. We also have a SPI programming header, just in case for whatever reason something goes wrong, you can re-flash the SPI and it will recover from potentially brick systems.
You can also, in the Arduino IDE, you can actually upgrade the SPI flash to the newest firmware that Intel's released. You just go to the menu and to firmware update, and it'll do it. It takes about 2 or 3 minutes, but you don't need any programmer. It just needs power and USB connection to your computer. So it's really easy to update the firmware.
That's right. Then we also have a 10-pin JTAG debug port. So if you want to do line-by-line debug and driver development down into Linux or down into the UEFI stack, you can do that with this and go step by step. We also have an RS-232 port, which looks like an audio jack, but it's not audio. It was meant to save space on the board and offer another access while you're doing programming and other things off the USB device port. You can be driving your Linux output through that RS-232. The physical board today is a 6-layer board. It was designed until the last minute to be a 4-layer board. We wanted to add some components to extend some of the features and functionality of it, but we didn't want to invalidate the design and have to go through another month of development activity, so we just added 2 layers and we kept going. But we do plan to simplify the board layers back down to 4 as we go forward. Right now it's a 10 centimeter by 7 centimeter board. We do plan to do smaller boards in the future, and again, different form factors. This just shows off one of the major devices. In reality, there's probably double of those devices embedded inside the socket. Of course, we're Arduino compatible. You want to talk about the Arduino compatibility?
Yeah, so the Arduino compatible, the only limitation on compatibility, any shield will work on it. The issue that we get into though is that because this isn't an AVR and it doesn't use the AVR architecture, you don't have the same registers as an AVR chip like the 18 mega 328P or the 32U4. So what you need to do to use a shield with this is, the shield needs to use the Arduino calls like digital write, digital read, analog write, analog read. It can't use port B equals port B or 0, 1, whatever stuff. But for it, Intel has tested a lot of shields, and about 25% of them work out of the box. Most of them with very little modifications and software libraries can be made to work with this. But all the pinout and all that is fully Arduino compatible. It also has down here, if you need to interface with 3.3 volt stuff, you don't need a level shift or anything. There's a jumper right here to select you want 3.3 volt logic or 5 volt logic. It comes at 3.3 volt, but it makes it really nice if you just want to, if you have something that's a bunch of 3.3 volt sensor stuff you need to interface with, you can just set it at 3.3 volt. You don't need any level shifters or anything like that.
Great job. As we talked about earlier, this is all open hardware and open software. We are supporting and working with Arduino on the software IDE right now. All the Linux firmware is up on the Intel website. You can go to maker.intel.com or go Galileo on the support site, and it will be there along with all the hardware documentation, the BOM, the schematic.
The IDE is currently it's a separate IDE on Intel's website, but eventually we should have a version of the main Arduino IDE.
And that's in a few weeks. Actually, that's one of the things we couldn't drive home just yet. But we're almost there with that. Is there any questions before we get to the cool stuff?
Yeah, so we don't, we're not board specialists, so if you have questions about the board, now's the time.
Yeah.
So I've heard from Massimo Banzi that they plan to release an HTML5 IDE. I don't know if you know of any plans for Galileo.
Yeah, we've been talking to David about that this week. We're really interested to do work with him on that. Right now, it's not ported over, but we do run Lua, which will expose to Java pieces, parts that he's working with for his web interface. So we're going to be merging that over time, yes.
So it is actually the same interface of Arduino, but it's more powerful.
Yeah, so this is actually, everything's Arduino compatible, but it runs Linux. So there are a few ways you can program this. You can either program it using the Arduino IDE and use all that. You can have a Linux program that you wrote interfaced with an Arduino sketch that you wrote. And you can write a Linux program that will actually interface with the I/O pins. You can write like a Python script that will interface with the I/O pins, but it's still just all Arduino compatible. Or you can write a low-level, like real-time operating system. So there's no Linux OS, it's just the code is running directly on the Galileo SoC, the Intel Core X1000 SoC.
Exactly. About the real-time operating system, can it deal with real-time scheduling or hard real-time scheduling?
It does a better job of it than previous Intel chips. We do some tricks to get the determinism a little bit tighter. It's not quite down to the 1 microsecond of variation level yet, but we're trending in that direction. It does run and it has good VxWorks, and we are working with Windows on some of the applications and demos that you'll see going forward.
Which distribution is real-time? Is there a specific Linux distribution for real-time applications?
The Linux one is just the tip of the tree Linux, right? And we're dealing with the Yocto project. So that's not real time by any means. We do have some tricks that we can do to map registers up into the user space, which gets a lot better real time, or I would call it real time performance, but better performance out, higher speeds, exactly. But if you want to go and do an RTOS like Windows VxWorks, that's going to be made available. We just haven't gotten there yet with our friends at the river.
Do you plan to make something like source for this kind of control?
Yes. And that's and like I said, we're talking right now with the river about that, and they already have it and they've moved it. They've been doing it for several months now.
How can I be familiar with our geographic applications?
We're going to be working through maker.intel.com. That's going to be our lead site for getting new data out the door. So there'll be a monthly update on that site.
So just check out
Yeah.
Maker.intel.com.
Yeah. Maker.intel.com. No problem.
Sure. So my name is Ainsworth.
I'm Carlos Montesino.
We're both researchers at the User Experience Research Lab in Intel's sort of R&D wing down in Santa Clara. And so we brought with us one project that we built using the Galileo. And this guy is what we call a DataMonster. So this project was built as an experiment around using gesture to convey emotions and mood, and also mixing data streams from the cloud. So the idea is we make something like a kit that you can download the patterns for. It's open source. If you'd like to, you can cut this pattern from a single 12 by 24 sheet of plywood or smaller at your local fab shop or Pinocchio.com. And the idea is you can build this structure or maybe other structures easily. We don't want you to get stuck on building the hardware. And then there are opportunities to program behaviors. So these data monsters, they interact in two ways. The first is they can see the world. So this one has, we're looking for power at the moment, but you want to sit on that?
It's gonna move a lot in.
Oh, we can hold it. So the first is the monster can see the world. So the monster needs to be able to interact with you. It needs to be able to recognize you and act in some way. This one has a series of 3 sensors that are sort of projecting out at 45-degree angles. And they fill this virtual XY space, so it understands where objects are. Very soon, when we built this just a couple weeks ago, OpenCV libraries weren't enabled yet, but as of now, I believe we have OpenCV. So in the next rev, we'll probably do a webcam, so the creature can do face tracking as well as motion. So you have a monster that can react to things that it sees, but it's also checking the web. So the idea is you have it listen to a web repository, Twitter, ThingSpeak, something like that. and you give the monster opinions about things in the world. So the monster likes, it's about to wake up finally. You could say, you know, my monster likes tweets about Lady Gaga and dislikes tweets about Justin Bieber, or whatever. And over the course of the day, as things change, the monster could perk up, become excited, or the monster could become lethargic. So, you know, we don't, it's really just an experiment. It's something that we can use for a dialogue to talk about data streams, to talk about programming a robot, things like that. Yeah, we just brought it here to show off.
So there's a tweet.
So that means that someone sent a tweet that has what it likes and then a little happy dance.
So there's Intel Labs, one of the research experiments is user experience, and we're all part of the UX group. And there's a lot of stuff that we're looking into and exploring, but specifically looking at how people and how technology, how to merge those two, how to bridge that gap is something we're really interested in. And this is an example of it. You can see, this is a conversation we've been having for a while. There's a lot of data being produced now on the internet, right? Tons of data. And all the tools that are available currently are typically for engineers. I mean, I'm an engineer, I love engineering, I love my XY graphs, make it 3D, make it 4D if you want. But there's a lot of people out there that want to interact with technology in a different way, right? And this is an instantiation of how we're exploring how you can communicate that data, that information, and share it with people, average people who are artistic, for example, people who don't care about the numbers necessarily, right? So, one example we've been given is, for example, instead of hooking it up to Twitter, you hook it up to the weather, for example. And you program the robot in a way that it happy dances when knowing that today is going to be a really good day to go to the beach, for example, right? So if you see the robot moving happy, you know, oh man, the weather's going to be really nice. However, though, if the robot starts moving slowly and it kind of like changes its motions, you know that the weather is going to be maybe not be a good day to go to the beach because it's just not going to be a nice day. It's just not going to be nice. So we're doing a lot of different type of research in our lab, and this is just one instantiation of how to communicate information in different ways, specifically through behaviors, through an actual 3D object, moving away from those 2D coordinating graphs.
And our intent is to build a repository of projects. We're hoping to build a repository of projects at makers.intel.com, where we will post this, the code for this, the schematics. If we build other hardware instantiations, I personally like the idea of building a few different structures for things that can act out data in different ways. And that will be all beyond.
There's a lot of opportunity for artists to express themselves with these type of technologies, and within Intel we have a lot of interest in enabling that as well. So it looks like we're going to see some of that stuff soon.
The other thing I wanted to say is, this being our first introduction into Maker activity. I know teams have worked before in Makers, like our friend Jay Milliken and the group and Carlos Contreras. But it's something which we want your feedback on. If you see us not doing something which you think we should be doing, let us know, and we'll adapt to what suits the Maker community. Right? That's why we're here. For open hardware, for open software, that's one thing. But also, if you see something which you want to see out of the silicon that I'm also responsible for, send us a request. We'll take a look at it, and we'll be able to spin silicon for these things relatively quickly. So you might be able to see your idea coming out on the other side, maybe in less than a year. Right? Also, if there's something missing on the boards, right? Go to maker.info.com, let us know what you want to see, and we'll be able to do something along with the friends of our community, and hopefully bring that to you so you guys can use it.
You had a question?
Yeah, like what
So the Wi-Fi, it doesn't have onboard Wi-Fi, but for about $10 to $15, you can get an Intel Centrino N130 Amazon for $10, and then you get the adapter for about $1-ish. And for it, you can just put that here, and then to get Wi-Fi, because the drivers that don't fit in SPI flash, you use a micro SD card. But for it, what you do is you can then put it in the mini PCIe slot on the back of the board here, and then you have full Wi-Fi capability. You can if you've seen the demo with the big light things, that they actually use Wi-Fi, and they use the Wi-Fi module to set up a Wi-Fi network where you connect to it and go to the website that it's hosting, and you can actually control the thing from that. So for it, all you really need is a micro SD card and the Wi-Fi module, the Intel Centrino N135 is what Intel recommends for the Galileo board. And you also need the adapter, and with that you can then go and set this up with Wi-Fi, and from there you can then have the project be wireless. So actually that's what this uses. It has a Wi-Fi module with the Wi-Fi antenna. So it's just connected to the Wi-Fi network here, so you don't need to plug it into Ethernet for this.
And for us, I mean, Carlos and I, well, Carlos is a programmer, but I'm a designer by training, so I come from a completely naive background. And once we got the board in and the files on the SD card, we just ran an Arduino, the example Wi-Fi sketch. So you just load that up and it works.
And also,
Do you have any plans to get that into the product?
We're looking at that right now.
and we also were, for this you can also, so all of your Arduino, like any Arduino Twitter stuff or any stuff like that, that will work on here, and some minor changes to code or even no changes, depending on how it's written. You can just load that on here, and you can have this connect to like Twitter over Wi-Fi or something like that.
Great question. And any more questions? Schuyler, do you want to talk some more?
Okay.
Go ahead.
Then the Galileo board, it also, for it, so for it, that's all there is. For it, you can also, as long as there are Linux drivers, you can put any mini PCIe 2.0 or 1.0 compliant device in here. So if you want to have this be a device where you don't need Wi-Fi, you can set it up with a cellular module, or, yes?
How do you play with the board? What do you do specifically?
What did you do first at the board?
What do you make of it?
So for it, when you first get it, what you do is you need to go to makers.intel.com or intel.com/support/go/Galileo.
What did you do?
What's guided?
It's okay.
I mean, outside to take the blong out of the box, rip it apart, and figure out how to do something else with it, plug it back into the board.
Well, for it, so the first thing I did was mostly I played around with the Linux on it some, and I got the networking over Ethernet really easy. I haven't gotten a Wi-Fi card yet, so I haven't tried that out, but yeah, there's enough plug it in, and I'll figure it. I haven't had much time to do much with it because I've just been really busy in the last few days, but it's really easy to set up. You just download your Arduino IDE from the Intel website, you unzip it and you run it. You plug in your board to, it needs power and USB. It can be powered off USB, but once you do that and then program it, it's actually really easy. You program it just like a regular Arduino, except it's the Galileo board. The programming it looks a little different. It'll say right into whatever register or whatever, but
I have seen him rip apart the box that it came in and remake the blong into something else.
yeah,
In about 5 minutes.
in the
He just pulled up soldering iron and went to soldering, pulling off the coin cells on it,
No, I
and
didn't.
pulling off the speakers.
No.
Oh, that's right. You left them on the
It's
side.
still completely functional. This has 3 wires coming off it. That's actually really funny.
But he also scared his dad, who's videoing this on this, because he took the blong out of the box in the first week, and he threw it into the refrigerator. It's light activated, so you open it up and it goes bong 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 bong, and
yeah,
not good first thing in the morning.
My brother was trying to find where was that noise coming from. So he's like, yeah, but box here at Maker Faire Go in it, and you open it. Depending on how bright it is, you either have to open up the whole box or just remove the board. There's a little board with a blob on it, some batteries, a speaker, a photodiode, and I believe it's a 3 meg or 1 meg resistor. And when it goes from dark to light, it'll trigger. So first was like, okay, how does it work? Then it was like, cool, I wonder where I'll put it. And then before I went, I was like, oh, I know, I'll hide it in the fridge. And then it was, I realized, here is like, I wonder if I can trigger it with the Galileo. So first, I found a point that was 5 volts and 1 lead of the photodiode, which was connected to the battery minus. And I thought, oh, the 5 volts is like the pull up or whatever and whatever. So I did it and it worked. So we tried triggering it with the Galileo and it would not work. Then when we measured it, it took 300 milliamps when you connected those 2 wires. And I was like, where does that 5 volt line go? And it turns out it's connected directly to the battery. So what's interesting is if you short out the battery, it will actually trigger the bomb and power it. So then I was like, okay, solder another wire to the other lead of the photodiode, and you connect the other lead of the photodiode to 5 volts, and then you disconnect it. That causes it to trigger the bomb without shorting out the battery.
So that was, while we were setting up the booth, at Intel, this is what Schuyler was doing.
Any other questions? Thanks,
All right,
everybody. And do let us know what you build with our board. We want to hear it. Thank you.
Thank you.